Greetings and welcome to week 5, unit 5 on course outcome statements. In the last unit, we understood what program educational objectives and program specific outcomes are. And now in this unit, we will try to understand the structure of outcome statements. In engineering programs, the graduates of engineering programs in India are required to attain the program outcomes as identified by the National Board of Accreditation and program specific outcomes identified by the university or the department offering the program. Okay. And POs and PSOs are to be attained through courses, projects, co-curricular and extracurricular activities in which performance of the students is evaluated. That should be remembered. You cannot say that we organize some lectures and we organize some events and so we are addressing all the concerned POs. You cannot say that. There the participation of the students needs to be evaluated. That means one has to define some rubrics and somebody has to sit down and evaluate the performance of the students. Coming to courses, they are broadly classified into core courses and electives that all of you are familiar with. Core courses are classified into, in India, professional core, engineering sciences, basic sciences, and humanities, social sciences, or management. POs and PSOs are attained through core courses, projects, internships, and activities in which all students participate. That is important. It is not that electives are not important, but any elective, by definition, not all students take the same elective. Okay. So, to that extent, we are focusing on activities where all students are involved, and through these common things you have to establish that POs and PSOs are attained. Yes, an elective can also contribute to attainment of PO, but only for selected students. That is the nature of electives. So many people consider that we are by not including electives into this attainment computations, we are somehow undermining the role of electives. No, electives are very important. They allow the student to specialize in some area or in some direction, and they are important. But only for the accreditation process, we confine ourselves to the activities in which all students are participating. And incidentally, courses constitute dominant part of any engineering program. Okay, if you have 160 credits, the electives may not constitute more than let's say 30 credits. So 130 credits are practically the common courses. And this is something that we mentioned earlier. It is important to remember as faculty. Students learn well when they are clear about what they should be able to do at the end of a course, that is course outcomes. Assessment is in alignment with what they are expected to do. That is, assessment should be in alignment with course outcomes. You declare this is the goal and I conduct my tests and examination assignments in something completely different, it doesn't make any sense. And instructional activities are designed and conducted to facilitate them to acquire and demonstrate what they are expected to do. So, which means alignment among instruction, assessment and course outcomes. This should be consciously be built into or planned to achieve. What are course outcomes? Course outcomes are what the student should be able to do at the end of a course. That's all. At the end, you may have a 2-credit course, 3-credit course, occasionally 4-credit courses, but the end of the semester, what he should be able to do is what constitutes course outcomes. CO is an effective ability, including attributes, skills and knowledge to successfully carry out the identified activity. The most important aspect of a CO is that it should be observable and measurable. One cannot write in such a way that it is not observable or measurable. Now we need to follow, or we need to have some kind of a structure when we are writing course outcomes. It will make it convenient to plan your assessment as well as instruction if you follow, if the CO statements have some well-defined structure. The structure of learning outcomes, these are also called as educational or instructional objectives, has been the subject of deep study in educational theory. For the last several decades, people have been talking about it. Some people slightly differ from the other and their practice, so this is an ongoing thing even now. Different educationists and theorists have proposed frameworks to define, classify and structure these outcomes in a way that can guide teaching, assessment and curriculum design. Okay, you follow certain structure for this, and it is not as if there is one correct way of doing it. Different people have approached differently. We will look at some samples. Robert Gagne, who was one of the early, in 50s and 60s, is well known in the area of education, instruction as well. He suggested 5 categories of learning outcomes: verbal information, intellectual skills, cognitive strategies, attitudes and motor skills. That means your course outcome should be concerned with one of these. Each outcome has specific internal conditions, that means learners' prerequisites, and external conditions, instructional support. He followed this for a large number of programs during 50s and 60s, and we are not going to follow that particular classification here. It is not that anything wrong with that, but we found something else a little more convenient in today's context. Robert Mager, who is another well-known, even today is active, he proposed that learning outcomes should be specific and measurable and structured COs as performance, 3 components. Performance, what should the learner be able to do? Condition, under what circumstances should he be doing that? And criterion, how well should they do it? That is his structure. In revised Bloom's taxonomy, or in revised Bloom, where the taxonomy is 2-dimensional, it is slightly modified from the Mager, but principally, rather as a principle, it is somewhat the same. Only the performance part is divided into 2 because we now make it 2-dimensional. We talk about cognitive process, that is, it is represented using an action verb, and knowledge types that you are using are knowledge elements belonging to different types. We consider, because you are performing this cognitive process selected cognitive processes on some knowledge elements. Then conditions and criteria, they are the same as that of Robert Mager. Okay. And there are two more where they try to combine a little bit of affective dimension as well into the classification. L.D. Fink, who is still active, he practices, encourages educators to structure outcomes around what the students will value and understand and be able to do after learning experience. So understand, able to do, they're covered already by both Mager and revised Bloom's taxonomy, but he added now one affective element called value. So some sample here, students will be able to develop an appreciation for ethical design, that is, he calls it caring, understand the impact of their designs on society, that is human dimension, and apply engineering principles to solve real world problems. Okay, that is how he has structured the outcome statements. Whereas Marzano and Kendall structured outcome statements around what the learner will do with what type of knowledge and using which systems or processes. So they add the human element to that. The learner will evaluate, that is cognitive activity, design alternatives is carrying information, using ethical and economic constraints. He calls it metacognitive, but we can consider it as some affective element. It is not exactly, at least in my view, it is not metacognitive. It has some affective dimension to that. We will not elaborate our views about these alternatives and so on. We will present as we suggest a structure to CO statements which is in line with that of revised Bloom, and we just slightly modify, because in engineering we would like to include vincenti categories of knowledge. So we will call it a revised Bloom Vincenti taxonomy, RBV taxonomy. An extension of the instruction can also address affective domain using the Goldman-Boyardz's ESI taxonomy, which we presented, and the spiritual domain, if you want to address, using Wigglesworth taxonomy. And what we proposed is, instead of exactly writing in the course outcome statement, we follow certain instruction processes, certain methods of instruction to address these dimensions. Okay. And they are captured through corresponding, whether the students have attained that or not, is identified through the using appropriate rubrics. So we shift it to the level of rubrics rather than directly into the CO statement itself. If it is possible, you can do so, but otherwise you can also follow this mechanism. The RBB taxonomy has 6 cognitive processes, and they are hierarchically arranged, and knowledge categories are 4 in number. They are 8 in number, not 4 in number. Okay, that's an error. And hierarchy means, if I have taken, let's say, analyze a cognitive process, it already implies the lower order, namely apply, understand and remember cognitive processes as well. So you don't have to separately mention them, unless, as we said, you want to ensure, as in our example, that he has mastered the lower level as well as higher level. Then if you want to emphasize that, then you use multiple action verbs. So the suggested structure for course outcomes has 4 elements: action, knowledge, condition and criteria, as already mentioned. And condition and criteria are optional elements. So this is how it is formally. Action represents cognitive, affective, psychomotor activity the learner should perform. An action is indicated by an action verb, sometimes by 2 or more action verbs, representing the concerned cognitive and sometimes affective processes. Okay. Knowledge represents the specific knowledge from any one or more of the 8 knowledge categories. Condition represents the process the learner is expected to follow, or the condition under which to perform the specified action. As we said, it is optional. We will see that we will show through examples that condition is not required to be mentioned in all CO statements. Criteria represents the parameters that characterize the acceptability levels of performing the action. This is an optional element of CO. If you are predominantly looking at psychomotor dimension, criteria become very important. They have to be part of every CO statement. Whereas it is kind of optional in the case of our cognitive and affective domain. When do we use 2 action verbs? We will go with specific example. Sometimes it becomes equally important for a student to perform 2 or more cognitive processes or sub-processes on a given knowledge elements. In such cases, 2 or more action verbs are used in a CO statement. Okay. It should not be used as an artifact to combine 2 COs into one. We have seen that also people doing. What they do, they write some large number of COs, and to reduce the number, take 2 COs and just add and give one long sentence. That is not on. The knowledge element should be the same. Then only you can use multiple action verbs. For example, draw Bode plot for the given dynamic system and determine the gain and phase margins. Okay. The Bode plot is the knowledge element. Drawing Bode plot is important. That means you should know the process of drawing, how to draw that, and then after that only you should know what are gain margins or phase margin and how do you determine that. So there are 2 action verbs, namely draw and determine. Okay, so you are using 2 action verbs and both the activities are equally important. Whereas if you don't use the draw, if you merely say determine the gain and phase margins of a given dynamic system using Bode plots, it assumes that somebody has given me the Bode plot and I am only concerned with gain and phase margins, how to determine them. But here we are insisting that you should learn how to draw and then determine the phase and gain margins. There is one instructional method called experiential learning. In experiential learning, students engage with a concept multiple times at multiple depths. That is the speciality of this. First verb may capture hands-on or direct experience, okay, which may be just apply, simulate or collect data. Second verb often involves higher order thinking and synthesis. That is evaluate, justify, create, it can be any of those activities. So using two verbs enables alignment with multiple stages of Kolb's cycle and allows for more holistic learning outcomes. Kolb's experiential learning talks about the holistic process where there are multiple iterations involved. So on the knowledge elements, you first experience something and then based on that experience, you do some higher order activities. That is the idea. For example, calibrate and validate industrial sensors using lab-based instrumentation kits. So what happens is calibrate is somebody has given you a process. This is the method, these are the steps that you need to follow to calibrate industrial sensors, and because of that you get some data, and then on the same data, on the same industrial sensors, you validate whether those sensors are in the exact operating range or acceptable or not acceptable. The validation process is it is almost like analysis type of or evaluate type of activity. Okay, that is the idea. So if you are following experiential learning instruction method, then you can use you can also use two action verbs. So coming back to we will look at several issues in the next unit also. First of all, course outcome should be unambiguous and comprehensible to students. Because what is the purpose of course outcomes? I am communicating as a teacher to the students at the beginning of the course what is it we are expecting them to be able to do at the end of a course. It is very clear. It should be clear to them. It may be clear to the teacher, but it has to be written in a way that it communicates unambiguously to the students, and there is no possibility of any ambiguity in that, because if each student understands slightly differently, then they are preparing differently. They should not be too abstract, neither they should be too specific. Sometimes people have written course outcomes like the way a problem is given in examination, one problem. One problem statement doesn't become a CBO. It is one example of your ability to do what is presented in the CBO. Okay, and when you write a CBO, it should have adequate scope to enable the instructor to design several assessment items. That is the way it should be written. Now we will look at a variety of examples. Sample 1, very simple one. Calculate major and minor losses associated with fluid flow in piping networks. Action is represented by the calculate, which belongs to apply, execute. Sub-process is execute. And knowledge, major and minor losses associated with the fluid flow in piping networks. It is both conceptual and procedural. How to calculate also is required, and then there are concepts in that. What do you mean by major loss, minor loss associated with the fluid flow? Both conceptual and procedural, and there is no condition and there is no criteria specified in this. Determine the dynamic unbalanced conditions of a given mechanical system of rigid body subjected to force and acceleration. Okay, first of all, it is general enough. That means I can change the description of the mechanical system of rigid bodies. I can specify it is a condition. So the action is determined, once again apply and execute. Why execute? The exact method of calculation has been presented in the class, and only in my assessment I will only modify some parameters of the problem, but it is something that is familiar, where exactly how to calculate is already presented to the student. Knowledge is dynamic unbalanced conditions. It is both conceptual and procedural, and condition is given mechanical system of rigid bodies subjected to force and acceleration, and there is no criterion. Now, third sample, determine the root of the given equation accurate to second decimal place using Newton-Raphson method. In the mathematics course, you are presented how to compute the root of a given equation, and action is determined, once again apply and execute, apply, sub process is execute. Knowledge is root of the given equation, and it is both conceptual and procedural. Condition is you have to use Newton-Raphson method, not by any other method. For example, I can also draw some curve and then say this is the root. Criterion is accurate to second decimal place. That is the criteria that if it is not accurate to the second decimal place, then you can say the performance is not acceptable. Now we look at, we may be dealing with multiple sub-processes in a cognitive process. And for example, in the case of understand, it will happen, there are 7 sub-processes, and you may want the student to be, should be able to perform the let's say 2 or 3 sub-processes on the same knowledge elements. In that case, we will use multiple action verbs. So we use corresponding action verb with respect to each selected sub-process, and this often happens in the case of understand, because there are 7 sub-processes. And even in analysis also, you will have 3 sub-processes. So in the case of understand, we may use either interpret, exemplify, classify, summarize, infer, compare and explain. You may use 2 or 3 or only one of the 7 sub-processes in writing or in addressing in a CO. Now, one example for that, classify digital modulation schemes. Classification is part of understand. Compare their bandwidth and power efficiencies. Comparison is also sub-process of understand. And summarize their suitability for given communication channels. So that's a good CO which captures all the intentions of the instructor with regard to modulation schemes. So action is classify, compare and summarize, all come under understand. Knowledge is modulation schemes and communication channels. And condition, there is none, and criteria, none. differentiate between, another sample, differentiate between the time domain and frequency domain signal representations, organize the steps for implementing digital filters, and attribute signal distortion to specific system components. So here action, differentiate, organize, attribute, all the three sub-processes are part of analyze. Knowledge is time domain and frequency domain signal representations, digital filters, signal distortion. So all these concepts need to be understood, and how do you compute anything with them. So it consists of both conceptual and procedural knowledge. Again, conditions are none, criteria are none. Now we come to how to connect COs and POs. As we mentioned, courses constitute significant percentage of the curricula. The program outcomes and program specific outcomes need to be attained predominantly through core courses and activities. Activities would mean projects, even internships if you want, any of that, seminars and so on. The course outcomes need to be written to address selected subset of POs, because predominantly you need to attain POs through courses. To that extent, that should get reflected in the way you write COs as well. CO statement should contain some action elements of selected POs. We have spent a significant amount of time in understanding each PO. Each PO has certain elements. If you are selecting some elements of that PO, then that should get reflected in the way you have written your CO as well. Now one sample. Assess the compliance of residential electrical installations with national safety codes and identify violations with 100% accuracy in at least 3 case studies. Okay. Somebody gives you a set of diagrams and of residential electrical installation, and you have to assess whether it follows the national safety codes. 3 case studies are presented to you. Can you identify any violations in that? That is the course outcome. Action, assess and identify. Assess comes under apply, and identify comes under analyze. 2 sub-processes of that. Knowledge is residential electrical installations. Theory of that, what are all the elements that go into that, all the safety issues are all explained with regard to that. Condition is using safety codes and case studies. Criterion is 100% accuracy in 3 or more case studies. And the PO alignment, if you are looking for, PO1 will always be there, because you are looking at an engineering problem, and you are using some, what do you call, knowledge from both mathematics and that particular engineering discipline and so on. And when you are using PO6, the safety is societal and legal issue. So to that extent you are addressing PO6. So that is how the PO can be brought into the writing of CO statements. Now all the samples that we have talked about, 6 of them, they can be located in the taxonomy table. Here what happens, because of the way we structure multiple action verbs and the knowledge elements also are in more than one, so they can all be captured like this. You can relate where how S1, S2, S1 is sample 1, S1, S2, S3, S4, S5, S6 are all located. If you look at S6, it is in apply procedural as well as analyze procedural. Okay, and it is also in the category of analyze criteria and specifications, apply criteria and specifications. It goes into 4 categories. And where does this help us? You can design, you would like to design your assessment items addressing all the cells that are occupied here. So you can say, can I ask a question to test whether the student has achieved this in this cell, which means that I have to design my question, instruct him correspondingly, apply and criteria and specifications. So by locating like this, I can make sure that I am instructing appropriately as well as assessing him appropriately. That is the idea. Okay. So RBV taxonomy table can effectively be used in engineering courses, but if your course is not truly engineering like any science course, mathematics course, you have only 4 knowledge categories. And in the next unit, week 6, unit 1, we will try to understand how to write course outcomes of good quality for a course. There are several other issues in addressing writing course outcomes, which we will explore in the next unit. And thank you for your attention.